Welcome to the deep dive. Today, we're heading way back into the late Cretaceous seas. We're doing a deep dive into, well, the undisputed rulers of those oceans, the Mosasaurs. And we're really zeroing in on the main genus, Mosasaurus.
A fantastic choice.
Our goal here is to pull out the most surprising facts, the key takeaways about these incredible predators from the source material you've got.
Absolutely. And it's a story that starts, maybe surprisingly, not out in some remote dig site, but right in Europe.
Oh, really?
Yeah, the very first fossils turned up back in 1764. That's near the Meuse River in Maastricht.
1764? That's way before people were finding most major dinosaurs, isn't it?
Exactly. Predates a lot of the big dinosaur discoveries. And that river, the Meuse, that's where the name comes from.
Ah, Mosasaurus. Meuse lizard. Makes sense.
Precisely.
Okay, so let's get the classification straight first, because people often lump them in with dinosaurs, mentally.
Right, a common mistake.
Heck.
But they're not dinosaurs at all.
They're actually part of the order Squamata.
That's it, Squamata. Which means they're essentially giant aquatic lizards. Or, well, related closely to modern lizards and snakes.
Giant sea lizards. Got it. And they dominated during the late Cretaceous period.
Yep. Roughly 94 to 66 million years ago. They really stepped into the apex predator role after other big marine reptiles like ichthyosaurs and pliosaurs started to decline.
Wow. And they evolved pretty fast to fill that gap, didn't they?
Extremely fast. Their adaptations for marine life are just incredible.
Okay, let's talk about how they moved. Because being related to snakes, you'd think, undulating, serpentine swimming.
That was the old idea, yeah. Like a sea snake kind of motion.
But the newer evidence points somewhere else.
It does. It suggests the more advanced mosasaurs actually had quite stiff bodies.
Stiff bodies? Why? Wouldn't that be less flexible?
It reduces drag.
Yeah.
Massively. And they combine that stiff body with a huge, powerful, crescent-shaped tail fluke.
Okay, so less like a snake, more like a shark.
Exactly. Think shark propulsion. Powerful thrust from the tail. It suggests they weren't constantly cruising, but maybe more like ambush predators.
Lurking and then, boom, high-speed attack.
Precisely. Built for that burst of speed.
And once they ambushed something, the feeding mechanics were something else. They kept that snake connection there, didn't they?
They're absolutely. The jaws were incredible, double-hinged.
And flexible skulls, too.
Yeah, flexible skulls, which meant they could, well, basically unhinge their jaws to swallow enormous prey. Almost whole sometimes.
Good grief. And what was on the menu?
Pretty much anything they could catch. Bony fish, sharks, sea turtles, marine birds.
Even other mosasaurs.
Oh, yes.
Yes.
Cannibalism wasn't off the table. And some, like blobodons, had these amazing, rounded, crushing teeth.
Crushing teeth? For what?
Perfect for hard-shelled prey.
Yeah.
Things like ammonites, big sea snails, they could just crunch right through them.
Incredible specialization. And the size, how big did they actually get?
The biggest one we know, well, Mosasaurus hoffmanni, could reach, estimates go up to about 12 meters.
12 meters? That's nearly 40 feet.
Yep, 40 feet of apex predator, right at the top of the food chain.
Okay, a 40-foot sea lizard. That requires some serious biological machinery. How did they power that huge body, especially if they were hunting in, say, deeper or colder waters?
And this, I think, is one of the most astounding findings. The evidence strongly suggests mosasaurs were endothermic.
Endothermic? You mean warm-blooded?
Essentially, yes, like mammals and birds.
Yeah.
They could regulate their own body temperature internally, keeping warmer than the surrounding water.
Wow. For a squamate, for a reptile, that's really unusual, isn't it?
Hugely unusual.
Yeah.
Apart from maybe one modern lizard, the tegu, it's basically unheard of in squamates. It would have given them a massive advantage.
Right, sustain energy levels for hunting, diving deep, maybe even surviving in cooler regions.
Exactly. And we find their fossils in places like Antarctica, which even back then would have been pretty chilly subpolar waters. Warm-bloodedness helps explain that range.
It paints a picture of a really high-performance animal.
Absolutely. And that high-performance biology extended to their reproduction, too.
How so? They didn't lay eggs on beaches like sea turtles?
Yep. No need for beaches. We found fossils of very young mosasaurs in deep water, open ocean sediments.
Meaning
They were viviparous. They gave birth to live young, right out in the open ocean.
live birth, and the babies were ready to go.
Seems like it. We call it precocial. The young were likely already effective swimmers, fully functional, not needing some kind of shallow water nursery, just born ready for life at sea.
So they're dominant, they're warm-blooded, live-bearing, ruling the oceans, but their reign came to a very abrupt end.
It did. Despite being at the absolute peak of their evolution, their success, they vanished.
The KPG extinction event, same one that got the non-avian dinosaurs.
That's the one. About 66 million years ago, everything just stopped for them.
And the sources mention a pretty dramatic final snapshot, right? Fossils found in a specific layer.
Yeah, some Mosasaurus remains were found in Missouri, actually, in what geologists call the Cretaceous cocktail deposit.
Cretaceous cocktail.
It's a tsunamite, a thick layer of jumbled sediment and debris laid down instantly by the absolutely massive tsunami triggered by the Chicxulub asteroid impact.
So literally caught in the immediate aftermath of the asteroid strike?
A catastrophic final moment preserved in the rock.
And with them gone, that apex predator spot was suddenly empty. It must have completely reshaped marine ecosystems.
Instantly.
Yeah.
A total restructuring. They left this enormous ecological vacuum.
Thinking about their biology again. That warm-bloodedness, the energy demands. You mentioned evidence of deep diving, too?
Yes. Some species like Mosasaurus conodon show bone damage, avascular necrosis, which looks like decompression sickness, the bends.
Scuba divers get.
Exactly. Suggesting they were doing frequent, repetitive deep dives, pushing their physiology right to the limit.
Okay, so that leads to a really interesting final thought for you, the listener. Consider this. These highly adapted, warm-blooded, deep-diving giants, arguably the pinnacle of marine reptile evolution at the time.
Yeah.
They were completely wiped out by the KPG event. But their cousins, the cold-blooded, seemingly less advanced lizards and snakes, they survived.
Right. Many squamates made it through.
It makes you wonder, doesn't it? Could that very high-performance, high-energy lifestyle that made Mosasaurs so dominant have also made them uniquely vulnerable to that sudden global catastrophe, while the slower, cold-blooded strategy proved more resilient in the end?
It's a fascinating, almost ironic twist, isn't it? Something to definitely ponder.